we've talked about now circles and ellipses, and today we're going to talk about the hyperbola. So a hyperbola is the set of all points in a plane, the difference of whose distances from two fixed points called the foci is constant. Remember, with an ellipse, we said the sum of their differences was constant. So now we're talking about subtraction, okay? So a hyperbola is the only conic section that has two parts. We call them the branches. And so an example of where you see something that is hyperbolic in shape is this example, this picture up here of the light coming out of the top and bottom of a lamp. Okay, so you have this shadow area in between, but here's where we have the two branches, the light coming out from the top and the light coming out from the bottom. That makes a hyperbola. What's important to know about a hyperbola is that it's not simply two parabolas put together, okay? A parabola, which looks like this, is constantly changing its rate of change. So these sides keep getting steeper and steeper and steeper. The rate of change is changing. With a hyperbola, it's really only rounded at the little elbow here, and eventually it levels off to be pretty close to linear on the edges. It's not going to be exactly linear, but it does get really, really close. And so that's one of the main differences between the two. And we'll see why they end up being straight on the sides here in a couple of minutes. So we need to talk about sort of the anatomy of a hyperbola, just like we did with all of the other ones. So a hyperbola can be horizontal, where the branches open to the left and the right. That would be both of these here are considered horizontal. It'd be vertical if it opens up and down. We measure it from the center, just the same way that we do with a circle and with an ellipse. These are going to have two foci. The foci are always going to end up like inside the little barrel of the branch there. And then the vertices are where the bottoms of the branches are, like the turning point of the branches. This axis in between the two vertices is called the transverse axis. Okay, so those are some of the things that we want to know about what we're looking for here. Okay, so here is the standard form equation of a hyperbola. Now remember, with ellipses, we said a squared always has to be the bigger number because with addition, order doesn't matter. But with a hyperbola, since the formula for a hyperbola has subtraction in it, that means that the order does matter. And so we can use the order to determine which is A and which is B. So for a hyperbola, what's different is that A squared is always first, okay? Now the X squared might be first or the Y squared might be first, depending on if it is horizontal or if it is vertical, but the A squared will always come from the first number. Now the equation to find the foci is different. This one is in fact the Pythagorean theorem. C squared equals A squared plus B squared. That's exactly what it's based off of. So that is how we will find our foci. So with an ellipse, it was A squared minus B squared. With a hyperbola, it's A plus B. So notice that the standard form equation of a hyperbola has a minus and the focus equation has a plus. The reverse of that is true for a hyperbola. Okay, so again, the one on the left is an example of a horizontal hyperbola, and the one on the right is an example of a vertical hyperbola. So we're going to start looking at this. We're going to start like you did the ellipses with center at 0, 0. So the first one says, find the vertices and locate the foci for each of the following hyperbolas. So let's look at the first one. The first thing I know is that since x squared is first, this is going to be a horizontal hyperbola, okay? I also know that A is equal to 4 and B is equal to 3. Remember, that's because of the order, not the size. If you look at example B there, for example B, this one is going to be vertical because y squared comes first. And A is equal to 3 and B is equal to 4 for this one. It's okay that A is smaller because it's the order that matters, not the size. Okay, so let's go back to part A. So the center is going to be 0, 0 because we don't have an HK. We haven't changed anything here. Since it's horizontal, we are going to change the x coordinate of the center. And so we're going to add and subtract a. So the vertices are going to be at 4, 0 and negative 4, 0. Then the foci, we're going to have to do a little bit of work to figure out. So we know to get the foci that c squared is equal to a squared plus b squared, which is 25. So that means that c is 5. So the foci are going to be at 5, 0 and negative 5, 0. And we'll practice graphing these here in a minute. So for B, it's going to be the same kind of rules, except this time because it's vertical, we're going to change the y coordinate of the center to get the vertices and the foci. So go ahead and pause the video and see if you can come up with those values. Here's what you should have. So again, we're leaving the x coordinate at 0. The y coordinate is where we're changing to locate the vertices and the foci. All right. Number 2 says, find the standard form of the equation of a hyperbola with foci at 0, negative 3, and 0, positive 3, and vertices at 0, negative 2, and 0, positive 2, as shown. So they gave us the diagram here. So remember, this is just like the one we did with ellipses. The foci, that's going to tell us the value of c. So we know that c is equal to 3. And the vertices are going to tell us the value of a. So we know that a is equal to 2. So we know that c squared, 9, is equal to a squared plus b squared. So that means b squared is equal to 5. And even though we don't really need it, that means that b is equal to the square root of 5. So this hyperbola is vertical, which means our equation is going to start with y squared over a squared, which is 4, minus, because now we're doing hyperbolas, x squared over 5, and that is equal to 1, just like in ellipses. It's always going to be equal to 1. Okay, now we talked a little bit about how the sides of a hyperbola end up being straight, and that's because they follow an asymptote. So they're going to level out and follow the path of this asymptote, okay? So the asymptotes, depending on whether it's horizontal or vertical, are going to depend on the values of A and B. And so you can think here, if it's horizontal, we're going to go up B and over A. So rise over run, the slope is B over A. Now for the other asymptote, I go down B and over A. So that makes the slope negative. If my hyperbola is vertical, I'm doing the opposite. I'm going up A and over B. So that's why it's the reciprocal for a vertical, because you're going up to the vertex first before you go to the right. Now, those values for B count to the left and the right, just like they did on an ellipse, but they're not really part of the graph. What the values of B help us do is to draw this rectangle, and the asymptotes always go through the diagonals of the rectangle. So that will help us graph these. So let's start by graphing one that is centered at the origin. Here's a summary of the steps, but let's go ahead and just talk through them together. So number 3 says graph and locate the foci for x squared over 25 minus y squared over 16 equals 1, and give the equations of the asymptotes. So we want the graph, the foci coordinates, and the equations of the asymptotes. So again, we've got to start with all of our pieces. So we have a center at 0, 0, and we know that this one is horizontal because x squared comes first. A is equal to 5, B is equal to 4, so c squared is equal to 25 plus 16, which is 41, so c is equal to the square root of 41. Now the square root of 41 is approximately 6.4. That's going to be helpful when we go to graph it, okay? So let's go ahead and graph, and then we can come back and answer the questions. So here's how this is going to work. I'm going to count by 2s on my graph because our values are a little bit large, and this graph only goes out to 7 on either side. So I'm going to say 8, negative 8, negative 8, positive 8. All right. So our center is at 0, 0. So I'm going to go ahead and draw my center. Since it's horizontal, A is going to count to the right and to the left, and that is going to give us our vertices. So that's where the 2 branches are going to go. So 2, 4, 5. Here's, come on, there we go. There's our first vertex. 2, 4, 5. If it'll draw, there we go. That's our second vertex. B is not really a point on the graph. So here's how I always do it. I always put a little dash because we're going to draw that dashed box. So that's where it starts. So the box has a width of 2 up and down, so a total width of 4. And horizontally, it has a width of 5 in either direction, so a total of 10. So our box, you can imagine where the corners are going to be. It's going to be right here, like this. Okay, so we need to draw that box so that the vertices are on the edges and the value of B takes you out to either side horizontally. And then we draw the diagonals, and which are the asymptotes. So that's another dotted line that's going to go through the corners, through the center. There's one asymptote. Here's the other asymptote. And then to graph these, we don't need to be very precise. We're just going to follow the asymptotes. So let me use a different color so you can kind of see. We're going to follow the edges and then curve so that we hit the vertex, and then follow the asymptotes out this way. Same on the other side. So like this. It's going to follow the asymptotes like a straight line and then kind of bounce off the box at the bottom. So now we can tell both by using our equation and looking at the graph, the vertices are going to be at -5, 0 and +5, 0. Now the foci, which we didn't plot on here, but let's go ahead and do that now, are at about 6.4. So that's going to be 6 and a little bit more. So the foci are going to end up somewhere about right there. And so that is going to be just the same as the vertices. It's going to change the x. So we have -square root of 41, 0 and +square root of 41, 0. And then the equation of the asymptotes, now you can count here. So looking at the boxes, remember they're 2. So we went up 4 and over 5. So the slope for the asymptotes is going to be y equals 4/5 x and y equals -4/5 x. The y-intercept is 0 because we went through the center. So that's y equals mx plus b. b is 0. Okay, so these are a little bit more involved to graph. You always want to start by graphing that rectangle. It's like an invisible rectangle, but that's going to help you the most with coming up with your shape. Okay, so for number 4, this is one where we have to do a little extra work to set this up, because just like we saw with ellipses, it's got to be equal to 1. So we'll start by dividing everything by 36. So the equation that we have now, I'm going to put it over here, is going to be y squared over 4 minus x squared over 9 equals 1. Pause your video now, see if you can go ahead and graph this one yourself. All right, this is what yours should look like. So go ahead and pause the video if you need to so that you can kind of take it all in and check your work along with mine. But now we're going to go ahead and move on and look at translations of hyperbolas. The only thing is we're moving the center, just like with ellipses. The rest of the process stays the same. Now, the equations of the asymptotes get a little bit trickier because the y-intercept is not 0 anymore. So we're going to have to use the slope and use the point that we know they go through, which is the center, to find the equations. Okay, so let's do one together. Number 5 says, graph the equation, find the foci, and what are the equations of the asymptotes. So just like we saw before, we can gather some information here. We know that the center, because we know how this works with HK and all of that, the center is going to be at +2, +3. This is going to be a horizontal ellipse because x squared comes first. A is going to be equal to 4, and B is going to be equal to 3, and that means that C is going to be equal to 5. A squared plus B squared equals C squared, okay? So go ahead and see if you can graph this using the new center. You're going to draw a box just like you did before, but instead of going from 0, 0, you're going to be counting from the new center. You might need to count by 2s, but it might be just enough to fit. So pause your video and see what you can come up with. All right, so here is what your graph should look like. This tells us that the vertices, remember that since it's horizontal, we're going to be doing everything to the x coordinate. So the vertices are going to be 2 plus a and 2 minus a. So that's going to be 6, 3, and that's going to be negative 2, 3. The foci, we're going to add 5. So that's going to be 7, 3. And we're going to subtract 5, which is going to be negative 3, 3. Now, to find the asymptotes, this is where it takes a little bit more work. Asymptotes. Okay. We have to use the point slope formula, which if you remember is y minus y1 equals m times x minus x1. That's a formula I expect you to have memorized. So we have to do that twice. So the two slopes that we need, the first slope is going to be up to, no, wait, what is that? Up 3 and over 4. So 3/4 is the first slope. The second slope is negative 3/4. They're just opposite signs. They're not reciprocals. They're just opposite signs. Now, both of these lines go through the center. So to do that, that's the ordered pair that we're going to use, which is the center at 2, 3. That's going to be our x1, y1 for the formula. So let's start with the first slope. So we get y minus 3 equals 3/4 times x minus 2. So that gives us y minus 3 equals 3/4 x minus 3/2. And then we have to add 3 to both sides. So we get y equals 3/4 x minus, well, it won't be minus. We're going to add 6/2 to both sides. So this becomes plus 3/2. So there's one asymptote. Now we just do that again with the second one. So go ahead and pause and see if you can find the equation of the second asymptote yourself. Alrighty, that is what you should have. And so you can look at the graph and see if we're kind of close. So for the one that has positive slope, the asymptote should be around 1.5, and that is about where it looks like it crosses the y-axis. For the second one, it should be about 4.5. And remember, we're counting by 2s, so that's pretty close to what we see, and we're graphed by hand, so that's not great, obviously. Okay, go ahead and let's look at number 6. Now on this one, this is just like with ellipses, how we have to complete the square, because this one is given in general form. So you're going to have to factor just like you did on ellipses. Now, notice that the x squared is positive and the y squared is negative. That tells us the order. We want to go x's first and then y's, which means it's going to be horizontal. If the x's were negative, then we would flip it around and it would be a vertical hyperbola. See if you can set this up and complete the square. So this is how we want to set it up. We're factoring out the coefficient. And notice that since it's a negative 25, it's also a negative 25 on the other side of the equation. So now we're going to complete the square. We should add 9 here and here. We should add 25 here and here. So now go ahead and factor that and get it equal to 1. So see if you can set up the rest of the equation. Okay, this one is a little bit of a trick because it looks right now like it's going to be a horizontal. But notice that this is equal to negative 100, and we need it to be equal to positive 1. When we divide by a negative, that's actually going to flip our signs. So what we have now is negative x minus 3 squared over 25 plus y minus 5 squared over 4 equals 1, which means we need to do a little switcheroo right here, and we'll end up with y minus 5 squared over 4 minus x minus 3 squared over 25 equals 1. Now you can find your center, your A, your B, you can graph it, you can solve for the equations of the asymptotes. I'm going to leave that for you to do on your own. But that is the extra thing we have to watch out for with hyperbolas, is even though it looks like the order might be one way, a lot of times it ends up flipping around. So that's where we're going to stop for today.